Hello and welcome to my 2024 GCSE Maths Predicted Paper 3 walkthrough. Now this is for the foundation tier, but I have also done a higher tier video as well. So if you are doing the higher tier, please check out my channel for that video. So I've taken this predicted paper from a website called Maths Genie. So I just want to say a big thank you to Maths Genie for providing the paper. It is freely accessible to view online. So what I've done is I've put a link to the paper in the video description. So what I recommend you do is click on that link and open up that paper, go through all of the questions yourself, and then when you've finished, you can check the answers, because I've also put a link to the answers in the video description. And if you are stuck on any of the questions, come back to this walkthrough and I'll go through the answers with you in this video. So you've done papers 1 and papers 2 so far, so there's all to play for. Hopefully you've done okay on those two, but don't worry, because you can always claw some of the marks back in paper 3. So just one last thing to mention is that I have got a playlist dedicated to past papers. So I always think the best way to revise is just by doing past papers constantly, all the time, over and over. So if you would like some more practice with past papers, please click on the link in the video description, which takes you straight to the playlist, and there's loads and loads of past papers to have a go at. So I think I've covered everything for now, so it's probably a good time to get straight on with the questions now. So let's get straight on with question number 1. Question 1, change 25 meters into centimeters. So we need to know our conversions between meters and centimeters. And there are 100 centimeters in a meter. So to go from meters to centimeters, we need to multiply by 100. So we're going to do 25 times 100. I do have my calculator here, but I don't think I need that. That's going to be 2,500. So it's going to be 2,500 centimeters. Question 2, write down 2 factors of 10. So what two numbers multiply together to get 10? Well, we can either have 1 times 10, or the other option is 2 times 5. So there are 4 factors. We've got 4 factors of 10. We've got 1, 2, 5 and 10. We only need to write down 2 of them. So I'm just going to say 1 and 10. You could have used 2 and 5. Either one of those you would get full marks for. Question 3, work out 3.5 squared. So for this one, we can use our calculator. So let's just type in 3.5 and then the squared button is up here. Press equals. Now we get our answer as a fraction. You can see the question, we've got it as a decimal. So if we just press this SD button, it gives us the answer as a decimal, which is what they want. So my answer is just going to be 12.25. No working out for this one on the screen because we're just typing this into the calculator. Question number 4. We need to shade 2/5 of this shape. So if we split it into 5 equal parts and then shade 2 of those parts, well, that's going to be 2/5. And lucky for us, we've actually got 5 columns. So if we break it into columns, we've got 5 different columns. And we're going to shade 2 of those columns. So that will be 1/5. That will be 1/5. And then if we shade another 1/5, well, now we've got 2/5. So this would be our answer. I'm not going to shade every tiny little bit here, but basically 1, 2, 3, 4, 5, 6 squares you need to shade. And it doesn't matter which 6 squares. You could pick random ones, but that would be a bit silly. But 6 squares out of these 15 you will need to shade. Question 5. Write a number in the box to make the calculation correct. So we've got 93.4 divided by something, and we get 0.00934. So the way I'm going to do this is I'm going to write down our number, 93.4, and we're trying to get to this number here. So what I'm going to do is I'm just going to put loads of zeros in front of our decimal point. Now we're going to move our decimal point. If we're dividing by 10, we move our decimal point to the left. So how many times are we moving our decimal point to the left to get this number? Well, this is 0.00934. So there's 2 zeros before our decimal. So that is where we're trying to get to. We've got 0.00934, and obviously these don't really mean anything here. I've just put them there as placeholders. So we're trying to get to this point. So we're going to divide by 10 once. So that would be divided by 10, divide by 100, divide by 1,000, divide by 10,000. So notice every time we move into the left, we're dividing by a multiple of 10 or a power of 10. So it would be 10, 100, 1,000, 10,000. So our answer is going to be 10,000. Question 6. Write one pair of brackets in this calculation so that the answer is correct. So at the moment, if we think about our orders of operation, we do the squared first. So 2 squared, well, that will give us 4. And then we do 3 times 5, which is 15. And then we've got 15 minus 4 minus 3. Well, we can see that 15 minus 4 is 11. 11 minus 3 is 8. So actually, if we didn't put any brackets in, our answer would be 8. Now, what can we do? Can we put brackets around anything here? Well, 15, if we were to put brackets around here, this would be 15 minus 4 minus 3. Well, 4 minus 3 is 1. So that would be 15 minus 1, which is indeed 14. So what I can do is I can put brackets around the 4 minus 3. So in our calculation, the 4 minus 3, that's just going to be this part here. Because 2 squared is 4, so 4 minus 3, if I put brackets around here, that is the same as this here. So we're going to have 15 minus this business, which is just simplifies to 1, and 15 minus 1 is 14. So this would be my answer. I've just put an arrow here. This is where my brackets would go. Question 7. Here are 6 triangles shown on a centimetre grid. 2 of the triangles are congruent. Write down the letters of these 2 triangles. So what do we mean by congruent? So congruent just means that one of the triangles can fit directly on top of one of the other triangles. So they're exactly the same shape and size. So let's think about these. It looks like we've got some right angle triangles here, and just by looking straight away, it looks like A and E are the same. Okay, it looks like E has just been rotated 90 degrees clockwise to A, and if we were to kind of turn it back, it would fit directly on top. But we can check that. So you can see that they're both right angles. They're both right angles. This one has a base of 2 centimeters and a height of 3 centimeters. And now this one, if we think about this being the base because it's been rotated, well, that is also 2, and the height is also 3. So if we've got 2 of the side lengths the same and a right angle on both of them, we know the hypotenuse is going to be the same. So I was correct. It is A and E, and I don't have to go any further. I don't have to check any more because only 2 of them are congruent. So all of these ones will be different. Question 8. In a shop, each jar of coffee costs £3.70. Harold has £50 to spend on coffee. Work out the greatest number of jars of coffee Harold can buy. So he's got £50 to spend, and each jar costs £3.70. So what we can do is just divide the £50 by £3.70. So in my calculator, I'm just going to do 50 divided by 3.7. And if we convert that to a decimal, I get 13.513, where the 5 and the 3 are recurring. Now, you can't say that he can buy 13.513 recurring jars of coffee. That doesn't make sense at all. So we're either going to round down to 13 or round up to 14. Now, even though this number rounds up, we cannot say that he can buy 14 jars of coffee because he doesn't have enough. He can only buy 13.5. So we're going to have to round down to 13 jars. Okay, he can buy 13 jars, but he can't buy 14. So my answer is going to be 13. Question 9. Nora gets on a train at 7:49 a.m. The train journey takes 2 hours and 45 minutes. Nora then walks for 18 minutes to get to a meeting. Does Nora get to the meeting before 11 a.m? You must show how you get your answer. So we know that she gets on a train at 7:49. And the train journey takes 2 hours 45 minutes. So let's add on 2 hours 45 minutes to this number. So we've got 2 hours 45 minutes. Now, if we add on 2 hours, so if we add on 2 hours, what's that going to take us to? Well, that's going to take us to 9:49. So now we just need to add on 45 minutes. So now we've just got 45 minutes. Now, I'm not going to add on 45 minutes to this. Let's do it in stages. So to get from 9:49 to 10 o'clock, what are we adding on? Well, we're going to be adding on 11 minutes. Okay, that's probably the easiest way to think about it. So 11 minutes, if we take away 11 minutes from 45, we're now left with 34 minutes. So if we now add on 34 minutes, we are now at 10:34. So notice, instead of adding on 45, all I did was added on 11 and then 34. So now we're at 10:34. Now let's move on to this part. It says Nora then walks for 18 minutes to get to a meeting. So if we add on 18 minutes, what do we get? Well, 34 plus 18 is 52. So that takes us to 10:52. So now let's look at the next statement. Does Nora get to the meeting before 11 a.m.? Yes, she does. And we can say she is how much early? 8 minutes early. 8 minutes early. So you don't have to say that she's 8 minutes early. You definitely need to say yes, and you need to give some numbers as to why it's yes. So I think if you just put 10:52, that should be enough. Or you can say that 11 o'clock is later than 10:52, something like that, should give you the full marks. Question 10. Here is a sequence of patterns made from sticks. Part A, in the space below, draw pattern number 4. So we're starting off with a square. So if I just do that, we've got these, looks like they're matchsticks. Pattern 2, you can see that we're just adding on 3 more to get 2 squares. And then pattern 3, we're just adding on another section to get 3 squares. So pattern 4, we're just going to do exactly the same. We're going to add on another 3 sticks to give us 4 squares. So this is pattern number 4. Now for part B, we need to complete the table. So we've got the pattern number and the number of sticks. So we can see patterns 1, 2 and 3, how many sticks there are. Pattern 4, I could count the sticks, but I can see from here that we're just going to be adding on 3 each time. So every time we go up a pattern number, we're just adding 3 sticks. So the next one is going to be 13, and then the next one, 13 plus 3 is 16. Okay, part C, work out the number of sticks in pattern number 10. So there's a few ways you could do this. You could work out the nth term. And I think I will do that just in case you get a question where you do need to work out the nth term. So to work out the nth term, we can see that our pattern is it goes up in 3s each time. So we know our nth term starts with 3n. Okay. Now, if we did have 3n, what would the sequence 3n be? Well, 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. But now, if we compare our 3n sequence with our number of sticks, you can see that our number of sticks is always 1 more than 3n. So 3n is 3. We need to add 1 to get to 4. 2 times 3 is 6. We need to add 1 to get to 7. 3 times 3 is 9. We need to add 1 to get to 10. So it's always 3n plus 1. So that is our nth term. So if we were working out the 10th term, which would be all the way over here, we would just do 3 times 10, which is 30, plus 1. That will give us 31. And actually, let's do that in that blue colour, 31. So the number of sticks will be 31. Now, that would be if we were doing the nth term. You could just, do it by brute force and just work out the number of sticks in pattern 6, 7, 8, 9, and then until you get to 10. And you can see we're adding 3 each time. So it would be 19, 22, 25, 28, and then obviously 31. So you would get the right number. But I think this way is much more elegant. And if it said work out the number of sticks in pattern number 270, obviously doing it like this would be a bit silly, and you'll be able to get the answer a lot quicker by using the nth term. Question 11. Bradley asked a group of people to name their favourite colour. He draws a pie chart to show his results. 17 of the people said that green was their favourite colour. work out how many people said that blue was their favourite colour. So the information we're told is that 17 people said green was their favourite colour. So this section represents 17, and we can see that that sector has an angle of 85 degrees. So we can say that 17 people is equal to 85 degrees, or not percentage, 85 degrees. So what we can do is we can work out what 1 degree is equal to. So we can work out what 1 degree is equal to, and then times that by whatever angle we've got for each of these sectors. So to work out what 1 degree is, we can just divide by 85. So if I do, what I'm going to do is 17 divided by 85. So 17 divided by 85, and we get 0.2. So we can say that 0.2 people is equal to 1 degree. Now at the moment that doesn't really make much sense, but let's go through each of these sectors. So for blue, if we did blue, well, we know that it's going to be 130 degrees. So it's going to be 130 degrees would be 130. And we know each degree is 0.2. So we're going to times that by 0.2. And I can do that in my head. That gives us 26, exactly 26 people. So there are 26 people who said blue. And that's what it's asking in the question. It says work out how many people said blue. I was going to do all of these, but there's no point. All I need is blue. So blue was 26 people, and that does make sense. It should be bigger than green, which is 17. I'm happy that the answer is 26. Question 12, part A, change $350 into euros. Now we've been given the conversion up here. We're told $1 is equal to 0.92 euros. So to go from 1 to 0.92, well, we are just going to be multiplying by 0.92. So however many dollars we've got, if we times by 0.92, that will give us our answer in euros. So we can do 350 multiplied by 0.92. So 350 times 0.92, and we get 322. And that is in euros. Let's write that down, euros. But in my answer line, I just need to type in 322. Okay, let's look at part B. It says change 200 euros into dollars. So this time we're going the other way. So to go from dollars to euros, we're multiplying by 0.92. So to go from euros to dollars, we're going to do the opposite. So we're going to divide by 0.92. So however many euros we've got, in this case we've got 200, we're going to do 200 divided by 0.92. So 200 divided by 0.92, and we get a nice long decimal here. So this is in dollars, so let's put our dollar sign in. We've got 217, and I'm just going to round to the nearest cent, so 0.39. So we've got 217.39. It doesn't say what to round to. I would probably say if you just put 217, you would also get the mark. Question 13. The drawing shows the positions of 3 towns, A, B and C on a map. The map has a scale of 1 centimetre is equal to 2.5 kilometres. Work out the real distance between town A and town C. Give your answer in kilometres. So we need to work out the distance from A to C. Now we can see what the distance on the map is because it's going to be 8 plus 15. So 8 plus 15. Well, that's going to give us 23 centimetres. And we know the scale. So the scale is 1 centimetre is equal to 2.5 kilometres. So we just need to multiply by 2.5. So I'm going to do 23 multiplied by 2.5. So 23 times 2.5. And that gives me 57.5. And notice our units. We're going from centimetres to kilometres. So this is going to be in kilometres, and that is what it's asking us to give our answer in. Give your answer in kilometres. So that is the answer, 57.5. Question 14. Cameron has some coins with a total value of 95 pence. She has only 2 pence coins and 5 pence coins, and the ratio of the number of 2 pence coins to the number of 5 pence coins is 2 to 3. work out how many 5p coins Cameron has. Now we need to be really careful here because we're told what the total value is, but with the ratio, this isn't the value of the 2p coins and the 5p coins. This is the number of 2p coins. So if we think about the number of coins, well, the ratio is 2 to 3. But now if we think about the value of the coins, what would the ratio of the value of the coins be? Well, the 2 corresponds to the 2p coins, so we're going to have to multiply that by 2. So if there's 2 2p piece coins, well, the total value is going to be 4p. So let's just put 4. And now if we think about the 5p coins, we've got 3 of them. They're each worth 5p. So we're going to times that by 5. 3 times 5 is 15. So this is the ratio we need now, is the value of coins, because we're told what the total value is. So what we can do is just add these numbers together. So we can do 4 plus 15, which gives us 19. So each part is worth 19p. So what we can do is we can divide 95 by 19. So we can do 95 divided by 19. So 95 divided by 19, and we get 5. So we can say that each part is worth 5p. Now, because we know that each part is worth 5p, we can work out the value for each of these coins. So we can just do 4 times 5, and that gives us 20p. And then we can do 15 times 5, and that gives us 75p. And you can see that 20p plus 75p is indeed 95p. Now, what it's asking us is work out how many 5p coins Cameron has. So our answer is not 75, that's the value. So how many does he have? Well, he's going to have 15, okay? Because 15 times 5 is 75. We know that the value is 5p each, and if we've got 75p in total, 75 divided by 5 is 15. So there are 15 5p coins. Question 15. The scale drawing shows the positions of 2 towns A and B. We need to find the bearing of A from B. Now this is really important. We're starting at B. So where it says from B, we're starting here and we're traveling to A. So we need to work out that bearing. We're not going from A to B, we're going from B to A. So bearings, remember, always start from north. So this is our north line that's drawn in. So we're going to start here, and we always go in a clockwise direction. So we're going in a clockwise direction. So we're going all the way around here until we get to this line, which takes us to A. So this is the bearing we're trying to calculate. So what I'm doing, I don't have a 360-degree protractor. So I'm going to measure this angle, and then I'm just going to take that away from 360 degrees. So bear with me while I put my protractor on the screen here. I'm trying to line it up as best as I can. And if I measure from 0, I get to 75 degrees, I think. So, oops, I just dropped it, but let's carry on. So that is 75 degrees. So what I need to do now is I need to do 360 minus 75. So 360 minus 75, and we get 285 degrees. So that is my bearing, 285 degrees. Question 16. 60 students study a language at a school. Each student either studies French or German. 36 of the students are boys. 2/3 of the boys study French. 40 students study French. Use this information to complete the frequency tree. So when there's quite a lot of information like this, let's just go through each point in turn. So we're told, first of all, that 36 of the students are boys. Now, we know the total number of students is 60, so we can put that straight in, and 36 are boys. So we can straight away work out how many girls there are just by doing 60 minus 36. So that will give us 24. So I know there are 24 girls. Now let's look at the next statement. 2/3 of the boys study French. So from the boys, 2/3 study French. So we need to take 2/3 of 36. So 1/3 is going to be 12. 12 times 2 is 24. So that's also going to be 24. So there's going to be 24 boys who study French. And therefore, to work out how many boys study German, we can just do 36 minus 24. And that gives us 12. There's 12 boys who study German. Now let's look at the final line. 40 students study French. So in total, the total number of students that study French is 40. We already know that 24 of them are boys. So to work out the number of girls that study French, well, we can do 40 minus 24. And that gives us 16. So we know there are 16 girls who study French. Now to work out the number of girls who study German, we can just do 24 minus 16. And that gives us 8. And we have filled in the frequency tree. Question 17, part A, we need to factorise this expression. So let's think first of all about the numbers. We've got 3 and 4. Now the highest common factor of 3 and 4 is 1. So we can't factor out any numbers. So let's turn our attention to the variables. We've got an a squared in this term and just an a in this term. So we can factor out an a. And that's all we can factor out because we don't have any b terms, b's in this term. So all we can factor out is an a. So in my brackets, so we're going to have 3 and then a squared divided by a, well that's just a. And then if we look at our second term, we've got 4, a divided by a is 1, so we've already dealt with the a's, and all we're left with is b. So that will be my answer, a, and then in our brackets, 3a plus 4b. Now let's turn our attention to part b. This time we need to solve. So there's a few ways you could solve this. You could expand the brackets, but what I'm going to do is I can see that we're multiplying everything in here by 3. So to get rid of this 3, I can divide both sides by 3. So if I divide this side by 3, we're just going to be left with g plus 9. And if I divide the right hand side by 3, 21 divided by 3 is 7. And then to get g on its own, I can subtract 9 from both sides. So we'll be left with g is equal to -2. So again, if you were to expand the brackets, let's just do that again, just to show you that you would get the same answer. So if you expand the brackets, you would get 3g plus 27 is equal to 21. And then if you subtract 27 from both sides, you're left with 3g is equal to -6. And then divide both sides by 3, you get g is equal to -2. So, hey presto, both methods, you get -2 as your answer. Question 18. Debbie buys 4 packs of oats. Each pack contains 750 grams of oats. The total cost of the 4 packs is £9.20. Work out the cost per 100 grams of oats. Give your answer correct to the nearest penny. So there's a lot of information here. And we're told that she buys 4 packs of oats and each pack contains 750 grams. So let's work out the total number of grams. Well, it's going to be 4 because there's 4 packs and each pack is 750. So we're just going to do 4 times 750 and we get 3,000 grams. So that's the total number of grams that she buys. And we know the total cost of the 4 packs is £9.20. So we can say that 3,000 grams must be equal to £9.20. And we need to work out the cost per 100 grams. So what is the cost per 100 grams? Well, to go from 3,000 to 100, well, we're going to be dividing by 30. So if we do 3,000 divided by 30, that takes us to 100. So all I need to do is divide this number by 30. So 9.2 divided by 30, press equals, and we get 0.306 recurring. And that is going to be in pounds. So if we were to give this to the nearest penny, to convert from pounds to pennies, I need to times by 100. There are 100 pennies in a pound. So that is going to be 30.6 recurring. So 6666 pence. Now we need to give our answer to the nearest penny. So we're going to need to round this up to 31 pence. So that's going to be my answer, 31 pence. Question 19. The diagram shows a solid prism. The volume of the prism is 804 centimeters cubed. Work out the value of x. So what we're going to do is, what I'm going to do is I'm going to write down an expression for the volume and then set that equal to 804. So how would we calculate the volume of this prism? Well, I'm going to split it up into two sections. So if I were to draw a line, let's draw a line down here. So if I calculate the area of this rectangle, calculate the area of this rectangle, add them together, and then multiply it by 8, that will give us the volume of this this prism. So this rectangle down here, we know the length is 9 and the height is x. So this is going to be 9x, the area. Now the area of this rectangle on the left hand side, well, we've got this length. Well, that's going to be 15 minus 9, so that's 6, and the height is 10. So 6 times 10 is 60. So the area, so let's just write this down. The area of the cross section is going to be 9x plus 60. And to work out the volume, so the volume, we're going to take this area and multiply it by the depth. So it's going to be 8 times by 9x plus 60. So what we can say is, we can say that 8 times 9x plus 60, the volume, that's an expression for the volume, well, that must be equal to 804, which is what we're told. So now I just need to solve this equation. So I think what I'm going to do first of all is I'm going to divide both sides by 8. So we're going to be left with 9x plus 60 is equal to 804 divided by 8. So 804 divided by 8. And we get 100.5. 100.5. And now if we subtract 60 from both sides, I get 9x is equal to 40.5. I think I've done that right. And now to get x on its own, we divide both sides by 9. So, well, we need to subtract 60 first. That gives us the 40.5, and then divide by 9. And we get 4.5. 4.5. So x is equal to 4.5. That looks about right. So we don't need to write centimeters because you can see it's 4.5 and then the centimeters are separate. So I'm going to say x is equal to 4.5. Question 20. The frequency table shows the time taken for 100 people to travel to an event. So you can see that there were 14 people who took between 0 and 10 minutes to travel, and 16 people took between 10 and 20 minutes, and so on. We need to draw a frequency polygon to show this information. Now, with a frequency polygon, a bog standard frequency polygon, we're going to use the midpoints of our intervals. So the midpoints of 0 to 10, we're going to use 5 minutes. So we go along 5 minutes and we're going to go up to 14 on our frequency axis. So each of these small squares is just 1. So 14 is going to be just there, just below our 15 line. So I'm going to plot each of these points. So we're going to go along to 15 and up to 16, which is there. We're going to go along to 25 and up to 23, which is there. Along to 35 and up to 29. Along to 45 and up to 12, which is there. And finally, along to 55 and up to 6, which is there. So we've plotted our points. Now we just need to connect our points with a straight line. So make sure you get your ruler out. I'm going to use the line tool and just draw a straight line to connect each of these points. So we're just going to be starting on our first point and then just keep drawing lines. And I don't mind, I won't begrudge you if you skip along because this might get a bit tedious. So please bear with me. I'm not going to edit the video. I'm just going to keep rolling. And if we put our last one in, we get here. And this is our frequency polygon. Question 21. Bradley gets the bus on Saturday and Sunday. The probability that Bradley's bus will be late on any day is 0.15. Bradley draws the probability tree diagram. The diagram is not correct. Write down 2 things that are wrong with the probability tree diagram. So we're told that the probability that Bradley's bus is late is 0.15, and that is on any day. So on Saturday it should be 0.15 and Sunday should be 0.15. Now straight away something's jumping out at me. I just said that it should be 0.15 on Saturday and Sunday, but here we've got 0.85. So one thing straight away that's wrong is on Sunday, the probability of being late should be 0.15, not 0.85. So we can clearly see what he's done wrong. He's just worked out the probability that it is not late. So what he's done is he's got these two switched around. Okay, now what else is wrong? Now what I'm seeing is just looking over on Saturday that this is correct, but now if we look at the probability that it's not late, this is wrong. And the reason I know it's wrong is I know that probabilities sum to 1. So what we need to do to work out the probability that it's not late is we need to do 1 minus 0.15, and that gives us 0.85. So that is the next thing that's wrong. We should say that on Saturday, the probability of being on time should be 0.85, not 0.75. So he's just made a mathematical error with this last one here. I'm not sure if there's any other errors. I think that's probably, these are the 2 main things that they're going to be looking for because it's worth 2 marks. Question 22. Matt wants to invest £8,000 for 3 years. He can choose between Bank A and Bank B, and we're told what the interest rates are for Bank A and Bank B. Which bank will give Matt the most interest after 3 years? You must show your working. So let's start with Bank A. So Bank A, we know he's going to be investing £8,000, so it's going to be 8,000. Now the interest is going to be 1.2% compound interest per annum. So our multiplier, if he's getting 1.2% interest, our multiplier is going to be 1.012. That will be a 1.2% increase. Now he's going to be doing that for 3 years, so we're going to raise that to the power 3. So we've got 8,000 multiplied by 1.012 to the power of 3, and we get a grand total of £8,291, and let's round that to 47 pence. So that is the amount of money he's got in his account, but we want to work out the interest. So now we can do 8,291.47 minus 8,000 to work out the interest, and that's just going to give us £291.47. So that is how much interest he would get from Bank A. Now let's look at Bank B, and let's just choose a different colour just to live on the edge. So Bank B, he's still going to invest £8,000. Now he gets 2% compound interest in the first year, so we can multiply that by the multiplier for 2%, so that will be 1.02. But then he gets 1% compound interest for each year after that, each extra year. So our second year is going to get 1.01, and then the third year is going to be 1.01 as well. So what does that give us? We've got 8,000 times 1.02 times 1.01. I can just do 1.01 squared, and that gives us £8,324, and let's round that to 2 pence. So to work out the interest, we can do 8,324 to 4.02 minus the original investment of 8,000, and we're left with £324.02. So we've worked out the interest from both banks. So which bank will give Matt the most interest? Well, we can say A. It might sound obvious. Not A. I'm almost made a mistake there. It's B. Obviously B. £324 is bigger than. Okay. We're not even getting to the end, but okay. So we all make mistakes. So it's Bank B. I'm glad I noticed that. And it might sound silly, but we need to say that £324.02 is clearly greater than £291.47, just to make it clear that we know that this number is bigger than this number. Question 23. The average daily temperature for 10 days is recorded. A shop also records its ice cream sales for each of the 10 days. The scatter graph shows this information here. Part A, what type of correlation does the scatter graph show? So there's three types of correlation. You can have a positive correlation, you could have a negative correlation, or you could just have no correlation whatsoever. But looking at the lines, you can see that it's going in a positive direction. So this would be a positive correlation. Okay, part B, on the 11th day, the temperature was 12 degrees. Estimate the ice cream sales on the 11th day. So what we need to do is we need to draw a line of best fit. So we can see the general line is going to be in this direction, and I think we sort of need a similar number of points either side of the line. So we've got 1, 2, 3, 4, 5 above, and 1, 2, 3, 4, 5 below. So actually that's not too bad. I'm quite happy with that. Let's just leave it as it is. So what we need to do is we need to go along to 12 degrees on the x-axis. So let's just go along to 12 degrees. So each of these points, or each square, or every two squares is going to be 1 degree. So if that's 10, that's going to be 11, that's going to be 12. So we're going to go up to the line. So if we go up to the line, we get to about here. And I'm just going to read off. So if I go along to the ice cream sales, we're going to get to this point here. So what is that? So it looks like if that's 150, that's going to be 140. I'm going to say 135. Now it is only an estimate, so there will be a margin for error. I'm not sure what that is. I will have a look at the answer sheet in a minute, but I'm going to say 135 degrees. So let's just take a look to see what they give. So they've got 130 degrees, so I'm not far out. So I probably would get full marks for this, I would say. So now let's look at part C. The shop's manager wants to use the scatter graph to predict the ice cream sales for a day with an average temperature of 2 degrees. Comment on the reliability of this prediction. Now, 2 degrees, notice what the minimum temperature was when he recorded the ice cream sales. And the minimum was, it looks like it was about 7 degrees. So this point here was 7 degrees. So the maximum was over here. It looks like it was about 21 degrees. So what we can do is we can only predict things that are between these two values. So because we're asking to make a prediction when the temperature was 2 degrees, we can say that the data will not be reliable, and that is because the temperature is outside of our data range, Obviously, you don't need to say this word for word, but as long as you're making the comment that it's not going to be reliable, and it's because our range of data only goes from 7 to 21 degrees, so obviously 2 degrees is outside of that. So any predictions have to be when the temperature is between the minimum and the maximum values. Question 24. Find 5% of this number. Give your answer in standard form. So to find 5%, we can just multiply it by 0.05. So we can do 3.8 multiplied by 10 to the power 105 multiplied by 0.05. So let's put all of that into a calculator. 3.8 times 10 to the power of 105 times by 0.05, press equals. Oh, we get a math error. So this number is too big to put into a calculator. So to work this out without a calculator, what I'm going to do is if I just switch this around, I'm going to do 3.8 times by 0.05 first. So I'm just going to put an X here. We can't do that. So if I cancel this and do 3.8 times by 0.05, well, that gives me 0.19. So now, instead of writing 3.8 times 0.05, well, I can just write this number. So we're now going to have 0.19 multiplied by 10 to the power 105. Now at the moment this is not in standard form. To write our number in standard form, our base number has to be between 1 and 10. So what we can do is to get this between 1 and 10, we can multiply this number by 10. So if we multiply by 10, we get 1.9. But if we're multiplying this number by 10, so if we are multiplying this number by 10, to keep the value the same, we have to do the opposite to this number. So we need to divide this number by 10. Okay, if we're multiplying one number by 10 and dividing the other number by 10, the number is going to be the same. So if we divide this number by 10, well, that's going to be 10 to the power 104. So we're just reducing this by a power of 10. And now this is in standard form, so that is my answer. 1.9, or let's make the 9 a bit neater, multiplied by 10 to the power 104. Question 25. Verity buys 12 bottles of apple juice for a total cost of £15. She sells all 12 bottles at £1.75 each bottle. Work out Verity's percentage profit. So how do we work out percentage profit? Well, we need to work out the difference. So the difference between what she buys them for and what she sells them for. And we need to divide that by the original amount. So what she buys them for, effectively. So that will give us our profit as a fraction. But we need to work that out as a percentage. So we just need to divide by 100. So we know what she buys them for. She buys them for £15, the total cost. What she sells them for is she sells all 12 bottles. So it's going to be 12 multiplied by £1.75 each. That's what she sells each of them for. So we can do 12 times 1.75. So she sells them for £21. So the difference is going to be 21 minus 15. We can see that's going to be 6, but I'm just writing everything down. And what the original amount, what she buys them for, is she pays £15 for them. So it's going to be 21 minus 15 over 15, and then we need to times that by 100. So let's just put in here 6 divided by 15, and then times by 100, and we get 40%. So that is our percentage profit, 40%. Question 26. Y squared times y to the power a equals y to the power 7. Find the value of a. So here we need to know our laws of indices. So when we multiply two numbers with the same base, we add our indices. So we know that these, if we add these together, that will give us our power. So all we can say is 2 plus a. We know that's going to equal 7. So a nice little equation here. We can subtract 2 from both sides and we get a is equal to 5. So, and you can check this. If you wanted to substitute 5 back in, we'll have y squared times y to the power 5. And just like I said, when we multiply numbers with the same base, we just add our indices. 2 plus 5 is 7. So our answer is 5. A is going to be equal to 5. Okay, part B, we need to find the value of B. And again, we need to use our laws of indices. This time, when we raise something to a power and then a further power, we multiply our indices. So we know that 4 times B must be equal to 12. So we can say 4B is equal to 12. And then to get B on its own, we divide both sides by 4. We get B is equal to 3. So again, you can check this if you wanted to substitute B into 3. 4 times 3 gives us 12. So B is equal to 3. Question 27. Change a speed of 81 kilometers per hour to a speed in meters per second. So we're starting off with 81 kilometers per hour and we need to change that in meters per second. Now the way I like to do this is I like to first of all focus on the distance and then look at the time. So we're going from kilometers to meters. So if we're going 81 kilometers in 1 hour, well, how far is that in meters? So to go from kilometers to meters, well, we're just going to multiply it by 1,000. There are 1,000 meters in a kilometer. So 81 times 1,000, well, that's going to be 81,000. So we're traveling 81,000 meters in 1 hour. So we've dealt with the meters part. Now we just need to think about the time part, so to get it in seconds. So let's first of all think about minutes. So let's think about in 1 minute, how far are we going to be traveling? Well, this is where a lot of people get confused because they think, well, to go from hours to minutes, I multiply by 60. So I need to multiply this number by 60, but that's not right. Think about this. If we're traveling 81,000 meters in an hour, well, we're going to be traveling a smaller distance in 1 minute. So we're actually going to be doing the opposite. We're going to be dividing by 60. We can travel 60 times less distance in a minute compared to an hour. So we're going to divide by 60. So we're going to do 81,000 divided by 60. And that gives us 1,350. So 1,350 meters in 1 minute. Hopefully that makes sense. Notice if we've got an hour to travel, we're going to travel a lot further distance. If we've only got 1 minute, we're going to travel 60 times less distance in 1 minute compared to 1 hour. Now let's do exactly the same thing for we've got a minute, but we want seconds. So in 1 second, well, again, we're going to travel 60 less times the distance. So we are going to divide again by 60. So we're going to do 1,350 divided by 60. And we get 22.5 meters. So we're traveling 22.5 meters in 1 second. So the speed is 22.5 meters per second. Question 28. The diagram shows a pentagon. Work out the value of x. So you need to know what angles in a pentagon sum to, and there is a formula for this. So it is the number of sides minus 2, and then we times that by 180 degrees. So pentagon has 5 sides. We could count this, but pentagon has 5 sides. So 5 minus 2 is 3. So it's going to be 3 times 180, and that gives us 540 degrees. So we know each of these 5 angles sum to 540. So we can say that 90 plus 98 plus 121 plus 92 plus x, well, that must equal 540. So now we just need to solve this equation. So let's add up all of these numbers first. We've got 98 plus 90 plus 121 plus 92. So that gives us 401. We've got 401 plus x is equal to 540. So now we can just subtract 401 from both sides, and we get x is equal to 139, not 1039, 139 degrees. Have I done that right? Yes, I think I have. 139 degrees. And that looks about right. It's an obtuse angle, so it's bigger than 90. So that's going to be my answer, 139 degrees. Question 29. The density of orange cordial is 1.21 grams per centimetre cubed. The density of carbonated water is 1.01 grams per centimetre cubed. A drink with a volume of 280 centimetres cubed is made by mixing 1 part orange with 7 parts of carbonated water. Work out the density of the drink. So how do we work out density? The formula for density is mass divided by volume. Notice we know what the volume is. The volume is 280. So it's going to be something divided by 280. We just need to work out what the mass of the drink is. So we know what the ratio is for orange to water. So we know the ratio is 1 to 7 for the volume. So to work out the volume of each part, well, we can just add these together. So this is 1 plus 7. 1 plus 7 is going to be equal to 8. And then we can do 280 divided by 8. So 280 divided by 8. And that gives us 35. So if we think about our orange and our water, the volume, so volume of orange, so I'm just going to put volume of O, well, that's going to be 1 times 35, which is equal to 35, and that is going to be in centimetres cubed. And then the volume of water, well, that's going to be 7 times 35, and that gives us 245 centimetres cubed. So we know what the volume is of each of these parts. We know what the density is. So to work out the mass, let's start with the mass of orange. Well, if we rearrange this formula, mass is going to be equal to density times volume. So the density of orange is 1.21. We times that by the volume of orange, which we just worked out, is 35. I think now I'm going to need to use my calculator. 1.21 times by 35, and we get 42.35. And if we think about our units, our density was in grams per centimetre cubed, and our volume was in centimetres cubed. So our units are just going to be in grams for the mass. And now let's do exactly the same for water. So the density of water was 1.01 times by the volume of water, which we worked out was 245. So 1.01 times 245, and that gives us 247.45 grams. So that we know the mass of each individual part. Now to work out the total mass, we can just add them together. So let's add these together. So I'm just going to add on 42.35, and we get 289.8 grams. So that is the total mass. So now I can substitute this all the way up here. So we're going to put in 289.8 up here. So that is the total mass divided by the total volume. So we're going to divide that by 280, and we get 1.035, and that is going to be in grams per centimetre cubed. So let's put that down there, 1.035. Now we can do a dummy check to make sure our answer seems sensible. And the density of the drink should be between the densities of the individual components. So we can see that it should be between 1.01 and 1.21, and it is. So I'm confident that this is the correct answer. So always do that dummy check. Question 30. The diagram shows a triangle ABC inside a semicircle. Work out the perimeter of the semicircle. Give your answer correct to 3 significant figures. So straight away I can see that we've got a right angle triangle. We've been given one of the side lengths and we've been given an angle. So what I'm going to do is I'm going to work out this side length, and the reason I'm working out this side length is this is the diameter of the circle, which we'll need when we calculate the perimeter of the semicircle. So I'm going to use SOHCAHTOA. So if I just write up here, SOHCAHTOA, let's think about which trig function we need to use. So from the perspective of this angle, our 51-degree angle, we've got the opposite side length. And this over here, well, that's opposite the right angle, so that is the hypotenuse. So which trig function involves the opposite and the hypotenuse? Well, it's the sine function. So if we write this out, the sine of our angle, the sine of 51 degrees, well, that's going to be equal to the opposite, which is 9, divided by the hypotenuse. And that's the one we're trying to work out. So if we just rearrange this equation, we can say that the hypotenuse is going to be equal to 9 divided by the sine of 51 degrees. I've just rearranged this equation. So let's put that into our calculator. 9 divided by the sine of 51 degrees, close brackets, and we get 11.5808. I've just rounded it to 4 decimal places, and that is in centimeters. So that is this length here, which is the diameter. Now to calculate the perimeter of a whole circle, let's imagine we've got a whole circle. So the perimeter would be pi times the diameter. So if we do pi times the diameter, that's the formula for the circumference of a circle. But because we've only got a half circle, we're going to divide that by 2. So what I've done there, so this pi times the diameter divided by 2, that will give us this half circle. So what I'm shading in blue. But then to calculate the perimeter of the semicircle, we just need to add on the diameter. So we need to add on the diameter. So if we put all of this into the calculator, we're going to have pi times the diameter, which is 11.5808. And then we're going to divide by 2. And then we're going to add on the diameter, which again is 11.5808. So let's put all of this into the calculator. And you can do this in stages. I'm going to do it all at once. So pi times 11.5808, and then divide that by 2, and then we're going to add on 11.5808, press equals, and we get 29. Now we need to give our answer to 3 significant figures. So that's going to be 29.8, because we're going to round this up. And that is going to be in centimetres. So that's my answer, 29.8. And I need to give my units because you can see that there are no units in the answer line. So I need to say centimetres. Question 31, and this is the final question of the paper. Solve x squared plus 3x minus 54 is equal to 0. So whenever we have a quadratic equation like this, we need to find 2 numbers that multiply together to give this number, so negative 54, and they need to add together to get this number here, so plus 3. So if we think about our factors of 54, we've got 1 times 54, we've got 2 times 27, we've got 3 times 18, and we've got 6 times 9. I think those are all of the factors of 54. Now we can see that the product is negative, so we know that one of these numbers has to be negative. And if we think about if they've got a difference of 3, because one of them is going to be negative, so when we add them together they'll have a difference of 3, which 2 numbers are we going to use? Well, we're going to use these 2 numbers. And if we think about which one is negative, well, you can see our sum is positive, so the bigger number has to be positive. So we're going to have 9 and negative 6. So those are our 2 numbers. If we think about 9 times negative 6 is negative 54, and 9 plus negative 6 is positive 3. So what we need to do is we just need to put in a double set of brackets, and we need to put one of them as x plus 9, and the other one is going to be x minus 6. So I have now factorised this expression. So now I just need to set that equal to 0. So we've got x plus 9 times x minus 6, and all of that is equal to 0. So because we've got two things multiplying by one another and the answer is 0, one of these has to be 0. So we can say that either x plus 9 is equal to 0, or we can say that x minus 6 is equal to 0. So we're going to have two solutions. Either x is going to be equal to negative 9, or x is going to be equal to positive 6. So those are our two solutions, 6 or negative 9. So we have come to the end of this paper. So I really hope that this is useful in your last exam. And I wish you the best of luck for your, not only your maths exam, but all of your exams that you're taking for your GCSEs. So best of luck and thanks again for watching. Hopefully I'll see you soon. Take care.